Now on to my final point about the crucial importance of knowing your audience. And it is that what you tell the audience or what you write to them or show them in a video is usually not what they will learn or take away from things. Often they can be very different, indeed quite often they can be the opposite. And it is extremely hard to predict what an audience will take away from any presentation or any document you provide them. I'm not going to tell you how to estimate what an audience will take away from it. That comes to some extent with experience. The main point is to be very aware that what the listeners come away with may not be what you told them. So you're sensitive to it and you build in feedback loops to check about it. I'm going to show you a whole bunch of examples of situations, some from my own experience, some from my readings, where people have made presentations, the audience have not behaved the way they expect, and this has caused enormous problems. Now, one that amazed me was a few years ago, I was teaching a course about telescopes and observatories, and I was talking about the best current observatories. This is the telescopes on the summit of Mauna Kea in Hawaii, which is probably the best observing site on Earth. 4,200 meters, beautiful smooth laminar airflow that gives you really sharp image quality. And this is the best observatory in Australia, Siding Spring Observatory, which we at the ANU own, which is a nice dark site, but has a lot more cloud, a lot more thermal, so the images are much more blurry. Now, I talked in my lecture quite a lot about different sites. I showed lots of pictures of different sites around the world. The very best sites are the no longer quite so good sites for observing. And in what I said, I focused on laminar airflow, the very smooth airflow that allows you to get really sharp image quality. Then, when I set an exam question about this a few months later, I got lots of very strange responses. Lots of people were saying, Siding Spring Observatory is not top rate because it's got too many trees. The trees disturb things. And I never mentioned the trees disturbing things. What had happened was that I was presenting two different messages. One from the pictures, which showed good observatory desert, bad observatory trees, and what I was saying, which is it's all about the airflow. But the pictures had completely overwhelmed the text. People had remembered the pictures. Bad observatories have trees, good observatories don't, and they'd ignore what I was saying, or forgotten what I was saying. This is a common analysis, that often the pictures have much more of an impact than text, and you have to be very careful about this. Now, I'm not saying always use pictures and not text, or always align the two. This will depend on the context. This is an example of something that surprised me. I thought they would listen to what I was saying, but no, they were listening to what I had shown on the screen. Here's another example from the book The Premonition by Michael Lewis. There were a series of disasters in the USA a few years ago when a tornado ripped through a town, killing dozens of people. And the US Weather Service was a bit worried and perplexed because in these cases the weather forecast had actually been quite accurate. They actually issued a tornado warning something like 12 minutes before the tornado hit, which is very good for tornado warnings. They'd been working for decades to try and get the tornado warnings to be more and more in advance, instead of 5 minutes in advance, to see the tornado coming maybe 10 or 15 minutes in advance and trigger the sirens so that people will go and run down into their bunkers or take shelter in bathtubs and be safe. But for some reason, there are a series of actually really nasty examples where, despite the warning coming out, and what for tornado warning was actually plenty of time, people just didn't respond. You'd given them the message, there is a tornado coming, take shelter, and they had not done so. Why not? And eventually they called in some social scientists to research this and actually survey the people and ask, why would sometimes people take huge amounts of notice of a tornado warning and sometimes they don't? What controls this? And it turned out to be a bit more complicated than people had thought. A lot of it determined by whether the town you were in had been hit by tornadoes in the past. If your town had been hit by tornadoes in the past, people usually took cover. If it hadn't, even if the town like 2 kilometers away on the other side of the river had been hit, people often did not take cover. And the reason was that people were making up stories to themselves. They were saying, oh, the tornadoes never cross the river. Oh, that hill means a tornado always veers off to the west. Yeah, we're in a different state. There are not so many tornadoes here. Now, these stories were not true. The tornadoes are actually controlled by atmospheric conditions in the high atmosphere, and things like rivers and small hills make no difference. It's just a random process. But these people had interpreted the random results in the past, like there had been 4 tornadoes over that side of the river and none over here, and they generalized quite wrongly that this meant tornadoes never came over here. It won't happen to them. Now, knowing this doesn't necessarily help, but it does mean you can target your communications a bit better to try and get people to actually take response if you know why they're not thinking about it. They're thinking, oh, it doesn't happen here, because they've made up some story in their mind based on, well, actually it was purely random statistics, but people are very good at seeing patterns, often spurious patterns, in random statistics. A big problem in education is misconceptions. Let's say I'm teaching introductory astronomy. I tend to assume that my students' heads are empty of astronomy and I'm filling them with my pearls of wisdom. But that's not true. For almost any real situation, people come to your class already with lots of often wrong ideas, and it's often more a question of unlearning what they've already got and then putting something new in. And these previous wrong ideas, so-called misconceptions, are a really serious problem. I was recently reading a book about one of the battles in World War II, and the Germans said that when they were fighting the Americans, it was harder than fighting the British. The British had a lot more experience. They'd been fighting for longer, but that meant they'd often learnt wrong lessons, and it was much harder to unlearn them, whereas the Americans, who didn't have a military before, were learning for the first time and could often pick up things more easily. Here's an example that's a major misconception in astronomy. Most people do not really understand why you get phases of the moon. They think wrongly that phases of the moon are due to the Earth's shadow. They're actually confusing eclipses and phases of the moon, which are actually quite different things. This is very, very hard to budge. You can tell people the right answer and they'll go, yes, 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 but if you test them 10 minutes later, they'll have reverted to their misconception. In the case of physics misconceptions, you can actually prove it wrong with an experiment, but then if you ask them a week later, they will have rewritten the memory of the experiment to conform to their misconceptions. Shifting misconceptions is very, very, very hard. Some would say almost impossible. Once people have got something in their brain, it's very hard to get it out. And this is something to be, I mean, there are techniques. If you do an education course, you'll learn about them, but it's very hard. So knowing what are the misconceptions that people have, what are they already thinking about, will often help explain their bizarre reaction to your communication. Another example from a book I was reading, again by Michael Lewis, was about preparation for pandemics. A group of scientists in the early 2000s had used computer modelling to come up with a new and surprising result. The conventional wisdom back then was if a pandemic comes through, there's nothing you can do apart from wait for a vaccine and get the hospitals ready. But these people had done some reanalysis of historic data and used computer models and said, actually, there is something you can do. While you're waiting for that vaccine, you can use social distancing and lockdowns and closing borders. And this went against the conventional wisdom. And these people were presenting over and over again. They'd present to audiences of experts and say, look, we think that in this situation, our modelling suggests that actually having, particularly closing schools, because lots of viruses are passed around by kids, can actually make a difference. It won't stop the pandemic, but it will slow it down a lot and therefore give you time to get the vaccines out and to prepare the hospitals. And they were finding, as they presented this over and over again, they weren't getting buy-in. People just weren't accepting it. They'd sort of nod politely, but they'd kind of somehow look evasive. They weren't really showing the body language that they accepted it. They tried presenting more facts and more data and better modelling, and it made no difference. So what was going on here? Well, eventually they figured it out. They figured out that they'd been addressing the technical issue, but not the emotional issue. Many of these people they were listening to had fought pandemics, and this was a really emotional thing. They might have had dying children in their arms and wailing people and crying. And to people from this background, this abstract computer modelling of pseudo-pandemics seemed somehow very uncaring, unfeeling. It was all very abstract. It didn't get to their heart. So eventually they had to change the presentation. They had to start presenting in a different way. They had to start off with something like, okay, here's a story from this pandemic. Here's this mother, and she's just lost all 7 of her children have died from the 1918 flu, one after another. It's terrible. But what could she do? There was no vaccine. Well, that is something she could have done. So going at it from the emotional angle first, and then pivoting to facts and presenting less modelling and more case studies, more examples, and it actually worked. They completely changed the official pandemic plan to allow for things like social distancing, which then spread around the world, and is what actually happened when COVID struck 15 years later. So in this case, they had thought that a logical presentation showing the simulations would work, and it didn't. There's probably no way they could have guessed it ahead of time. They just needed to listen a lot. A personal example. Back in several years ago, I applied for promotion to professor and was rejected. And with the benefit of hindsight, I had made almost all these errors. I had to give a talk about why I should be promoted to a committee of professors. And I knew that the chair of the committee was the deputy vice chancellor and knew all about the work I was doing on online education. So I kind of assumed the committee knew why online education was important. And the chair did, but the chair is not allowed to influence the rest of the committee, and most of these people were senior research professors who had no idea of the value of what I was doing. So I'd become too suckered by thinking about the one expert and not the average of the people in the room, but of course I needed the average to vote for my promotion. There was also a misconception that it took me a long time to figure out. I've always been very proud of what I call an experimental approach to teaching. Paul's first law of teaching is that no teaching plan ever survives contact with the students. You can try the best teaching approach that comes recommended by all the books, it can completely not work. To me, this means that the correct way to deal with teaching, and in fact all communication, is an experimental approach. You try lots of different things and you see what works for that particular audience. What works for this class in this year might not work for that class in that year. So you have to try it out. Try it out in a low-stakes environment where it's not going to hurt student grades, and then see what works. This is the whole Silicon Valley mantra. Fail early, fail often. Try lots of things, see what works, improve the ones that work, throw away the ones that don't. So I presented this in my promotion case as my teaching philosophy, and it was a disaster. I think for most scientists, that experimentation is seen as a good thing. It's a sensible, reasonable approach. But for many people from the humanities, this is a very bad idea. Experimenting with students sounds like a self-indulgent professor sticking probes in student brains. It's a negative connotation, which is something I wouldn't have realised because I tend to hang out with other scientists, and we think that experimentation is a good and humble way. It's not being arrogant, not assuming you know what's going to work for the students. But for many people in the audience, experimentation is an arrogant approach where you're prioritising your own knowledge over the well-being of students. So a few years later I tried again and got promoted by paying attention to these things. So the point I'm making is not these specific problems and misconceptions, though hopefully they're interesting. It's that it's very hard to predict how an audience will respond to your writing, your speaking, whatever it might be. So you have to be very sensitive, you have to listen to them. So listening to your audience is arguably more important than speaking to them. Get to know your audience, see how it worked, trial and error, experimental approach. It's absolutely fundamental to good communication.